Hello everyone, welcome to Eastern Block. In this series of Azure training, we will be looking at Azure Identity, Access and Security. So in our previous videos, we saw like Azure Cloud Concepts, Azure Core Architectural Components, Azure Compute and Networking Services, Azure Storage Services, and this will be about Identity, Access and Security. So the topics covered in this session are like about Azure Active Directory Services, Azure Active Directory Domain Services, Azure Authentication Methods, Azure Conditional Access, Azure External Identities, Azure Role-Based Access Control, Azure Zero Trust Model, Defense in Depth, and Microsoft Defender for Cloud. So first we'll be discussing about Azure Active Directory. So Active Directory is related to Azure AD, but they have some key differences. Microsoft introduced Active Directory in Windows 2000 to give organizations the ability to manage multiple on-premises infrastructure components and systems by using a single identity per user. For on-prem environments, Active Directory runs on Windows Server, provides an identity and access management service that's managed by own organization or own engineers. So Active Directory is Azure Active Directory is Microsoft's cloud-based identity and access management service. With Azure AD, you can control the identity accounts, but Microsoft ensures that the service is available globally. If you work with Active Directory, Azure Active Directory will be familiar to you. So if you know Active Directory, obviously it will be easy for you to understand Azure Active Directory. When you secure identities on-prem with Active Directory, Microsoft doesn't monitor sign-in attempts. When you connect when you connect Active Directory with Azure AD, Microsoft can help protect you by detecting suspicious sign-in attempts at no extra cost. For example, Azure AD can detect sign-in attempts from unexpected locations or unknown devices. So who uses Active Directory? So Azure AD is for IT administrators, app developers, users, and online service subscribers. So talking about the IT administrators can use Azure AD to control access to applications and resources based on their business requirements. So talking about the app developers can use Azure AD to provide a based approach standard-based approach for adding functionality to applications that they build, such as adding single sign-on functionality to an app or enabling an app to work with a user's existing credentials. Talking about the users can manage their identities and take maintenance actions like self-service passwords, resets, etc. For online service subscribers like Office 365 or MS Office 365, Azure, and Microsoft Dynamics CRM, online subscribers are already using Azure AD to authenticate into their accounts. So what does Azure AD do? So you have authentication, single sign-on, application management, and device management. So talking about the authentication, this includes verifying identity to access applications and resources. It also includes providing functionality such as self-service password reset, multi-factor authentication, a custom list of banned passwords, and smart lockout services. Talking about the single sign-on, so-called SSO, enable you to remember only one user and one password to access multiple applications. A single identity is tied to your user, which specifies the security model. As users change roles or leave an organization, access modifications are tied to that identity, which greatly reduces the effort need to change or disable accounts. So application management, you can manage your cloud and on-prem apps by using Azure AD. Features like application proxy, SaaS apps, the My App portal, and a single sign-on provide a better user experience. So talking about the device management, along with accounts for individual people, Azure AD supports the registration of devices. Registration enables devices to be managed through tools like Microsoft Intune. It allows it also allows for device-based conditional access policies to restrict access attempts to only those coming from known devices, regardless of the requesting user's account. So we'll discuss about connecting on-prem AD with Azure directory services. So you can simply able to understand this picture. So if you had an on-premises enabled on-premise environment running Active Directory and a cloud deployment uses Azure AD, you would need to maintain two identity sets. However, you can connect Active Directory with Azure AD, enabling a consistent identity experience between cloud and on-premises. One method of connecting Azure AD with your on-prem AD is using Azure AD Connect. Azure AD Connect synchronizes user identities between on-premises Active Directory and Azure Active Directory. Azure AD Connect synchronizes changes between both identity systems, so you can use features like single sign-on, multi-factor authentication, and a self-service password reset under both systems. So Microsoft Azure provides a free tool a tool which you can install on your on-prem server, which when you install on server and when you configure, it will synchronize the passwords, users, everything. So we will do that in our labs, upcoming labs, how to install Azure Connect and configure sync with on-prem AD and cloud. So talking about the Azure Active Directory domain services, so the question, what is Azure Active Directory domain service and how does Azure Active Directory domain services work? So this picture little bit explains about it. So Azure Active Directory Domain Services is a service that provides managed domain services such as a domain join, group policy, lightweight Active Directory, access protocol, so-called LDAP, Kerberos NTLM authentication. Just like Azure AD lets you use directory services without having to maintain the infrastructure supporting it. With Azure ADDS, you get the benefit of domain services without the need of deploy, manage, and patch domain controllers in the cloud. And Azure ADDS managed domain lets you run legacy applications in the cloud that can't use modern authentication methods, or where you don't want directory lookups to always go back to an on-prem Active Directory service environment. You can lift and shift these legacy applications from your on-prem environment into a managed domain without needing to manage the Active Directory domain services environment in the cloud. So Azure Active Directory domain service integrates with your existing Azure AD tenant. This integration lets users sign into services and applications connected to the managed domain using their existing credentials. You can also use existing groups and user accounts to secure access to the resources. These features provide a smoother lift and shift of on-premises resource to Azure. So the question comes, how does Azure Active Directory domain services work? When you create an Active Directory domain services managed domain, you define a unique namespace. This namespace is the domain name. Two Windows Server domain controllers are then deployed into your selected Azure region. This deployment of DCs is known as a replica set. So you don't need to manage, configure, update these DCs. The Azure platform handles the DCs as part of the managed domain, including backups and encryption at rest using Azure Disk Encryption. So how the information is synchronized? That's the question. So a managed domain is configured to perform one-way authentication, one-way synchronization from Azure AD to Azure ADDS. You can create a resource directly in the managed domain, but they won't synchronize back to Azure AD. In a hybrid environment with an on-premises Active Directory Services environment, Azure AD Connect synchronizes identity information with Azure AD, which is then synchronized to the managed domain. So pretty simple to understand here. So this picture shows how it works, how it synchronizes. Next comes why secure access. So traditionally, protecting access to systems and data involved the on-premises network parameter and physical access controls. With people increasingly able to work from anywhere, plus the rise of bring your own devices strategies, mobile applications, cloud applications, many of these access points are now outside the company's physical network. Identity has become the new primary security boundary, uh, accurately proving that someone is a valid user of your system with an appropriate level of access is critical to maintain control of your data. So this identity layer is now more often the target of attack than the network is. So retail employees located around the world are issued tablet devices from which they can create orders for the customers, track delivery schedules, and even plan their work schedules. Delivery drivers can use their own mobile devices to access scheduling and logistics applications. So organizations across uses Active Directory to secure its on-premises environment. It need to ensure that only employees can sign in and access the company's business application. It also need to ensure that short-term staff can access this application only when they are under active contract. So if you see here, like only the employees or only authenticated users can connect to the network, and any hacker should not log into your network. So that is the reason we are discussing why secure access is critical. So talking about the authentication methods, authentication is the process of establishing the identity of a person, service, or device. It requires the person, service, or device to prove some type of credentials to prove who they are. So authentication is like presenting ID when you are traveling. It does not confirm that uh, you are ticketed. It just proves that you are who you say you are. So Azure supports multiple authentication methods, including standard passwords, single sign-on, multi-factor authentication, and even passwordless. For the longest time, security and convenience seems to be at odds with each other. So yeah, thankfully new authentication solutions provide both security and convenience. So here the following picture shows the security level compared to the convenience. So notice passwordless authentication is high security and high convenience, while passwords on their own are low security with high convenience. So we need to compare authentication with authorization. That the two fundamental concepts that you need to understand when talking about identity access or authentication and authorization. Authentication and authorization both support everything else that happens. They occur uh, sequentially in the identity and access process. So what is authorization and what is authentication and what is authorization? So Authentication is the process of establishing the identity of a person or service that wants to access a resource. It involves the act of challenging a party for legitimate credentials and provides the basis for creating a security principle for identity and access control. It establishes whether the user is who they are say they are. So what is authorization? Authorization is establishes the user's identity, but authorization is the process of establishing what level of access an authenticated person or service has. It specifies what data they are allowed to access and what they can do with it. So what is single sign-on? So we are discussing multiple times. We are taking the name single sign-on. So single sign-on enables a user to sign in one time and use that credentials to access multiple resources and applications from different providers. So more identities means more passwords to remember and change. Password policies can vary among applications. As complexity requirements increase, it becomes increasingly difficult for users to remember them. The more passwords a user has to manage, the greater the risk of credential related security incidents. Consider the process of managing all those identities. Additional strain is placed on help desk as they deal with account lockouts, password resets, requests, etc. If a user leaves an organization, tracking down all those identities and ensuring they are all disabled can be a challenge. If an identity is overlooked, this might allow access when it should have been eliminated. With SSO, you need to remember only one ID and one password. Access across applications is granted to a single identity that's tied to the user, which simplifies the security model. As users change roles or leaves an organization, access is tied to a single identity. The change greatly reduces the effort need to change or disable accounts. Using SSO for accounts makes it easier for the users to manage their identity and increases your security capabilities. So here you can see we have multiple partners or multiple customers using a single sign-on. They can log into multiple applications. So this picture it's there to make it understand pretty simple. So question is how single sign-on works. Looking at the picture, you can see like how it is working. So how does a single sign-on web browser with seamless SSO works? So the user tries to access a web application. For example, a user is trying to access his mailbox using outlook.microsoft.com/OWA. For a domain joined corporate device inside your corporate network, if user is not already signed in, the user is redirected to the Azure AD sign-in page. User types in his username into the Azure AD sign-in page. So Azure using JavaScript in the background, Azure AD challenges the browser via 401 unauthorized response to provide a Kerberos ticket. The browser in turn requests a ticket from the Active Directory for the Azure read SSO ACC computer account, which represents Azure AD. Active Directory locates the computer account and returns a Kerberos ticket to the browser encrypted with the computer account's secret. The browser forwards the Kerberos ticket it required from Active Directory to Azure AD. Azure AD decrypts the Kerberos ticket, which includes the identity of the user signed into the corporate device using the previously shared key. After evaluation, Azure AD either returns a ticket back to the application or asks the user to perform additional proofs, such as multi-factor authentication. If the user sign-in is successful, the user can access the application. So whatever I'm saying, it's pretty simple to understand here. So it all works in background. So somewhat theory, but if you know the process, it will be easy for you uh, some while troubleshooting some issues. So talking about the multi-factor authentication, multi-factor authentication is a process where user is prompted during the sign-in process for an additional form of identification. Examples like include a code on their cell phone or a fingerprint scan. So think about how you sign into a website, email, or online gaming services. In addition to your username password, have you ever need to enter a code that sent to your phone or a mobile? If so, you are using multi-factor authentication to sign in. So multi-factor authentication provides additional security for your identities by requesting two or more elements to fully authenticate. So there are like three categories of elements, like something the user knows. This might be an email address and a password. So this is what we are discussing about. So something the user has, so it might be a code that's sent to your cell phone, like you will get SMS when you try to log into your application, so it will push and it will send a code, or it will push a pop-up when you click tick mark, or when you click OK, you will be able to log in. Something the user is, this is typically some sort of biometric property, so such as fingerprint or face scan that's used on many mobile devices. So the latest mobiles will have, when you want to unlock the mobile, it will scan your face, and if it matches, then only it will open. Such type of technologies. So like even using the fingerprint, you will be able to access the application. So multi-factor authentication increases identity security by limiting the impact of credential exposure. For example, stolen username and password. With multi-factor authentication enabled, an attacker who has a user's password would also need to have a position of their mobile or their fingerprint, or fully authenticate. So compare multi-factor authentication with single sign-on authentication. Under single factor authentication, an attacker would need only a username password to authenticate. Multi-factor authentication should be enabled whenever possible because it adds enormous benefits to security. So talking about the Azure AD multi-factor authentication, Azure AD multi-factor authentication is a Microsoft service that provides multi-factor authentication capabilities. Azure AD multi-factor authentication enables users to choose a additional form of authentication during sign-in, such as a phone call or mobile app notification. So this service provides Azure AD multi-factor authentication capabilities. So Azure Active Directory is a free edition, enables Azure AD multi-factor authentication for administrators with the global admin level of access via the Microsoft Authenticator app, phone call, or SMS code. You can also enforce Azure AD multi-factor authentication for all users via Microsoft Authenticator app only. By enabling security defaults in your Azure AD tenant. So Azure AD, Azure Active Directory consists of two licenses P1 and P2 premium, allows for a comprehensive and granular configuration of Azure AD multi-factor authentication through conditional access policies. So talking about the multi-factor authentication for MS Office, a subset of Azure AD multi-factor authentication capabilities is a part of the default Office 365 subscription. So next is like passwordless authentication. So features like multi-factor authentication are a great way to secure your organization, but Users often get frustrated with the additional security layers on top of having to remember their passwords. People are more likely to comply when it's easy and convenient to do so. Passwordless authentication methods are more convenient because the password is removed and replaced with something you have, plus something you are or something you know. Passwordless authentication need to be set up on a device before it can work. For example, your computer is something you have. Once it's been registered or enrolled, Azure knows that it is associated with you. Now that the computer is known, once you provide something you know or such as PIN or fingerprint, you can be authenticated using without a password. Each organization has different needs when it comes to authentication. So Microsoft Global Azure and Microsoft Government offers the Azure Government offers the three passwordless authentication options that integrate with Azure Directory, that is AD Directory, Azure Directory. One is Windows Hello for Business, Microsoft Authenticator app, and FIDO2 security key. So talking about the conditional access is a tool that Azure Active Directory uses to allow or deny access to resources based on identity signals. These signals includes who the user is, where the user is, and what device the user is requesting access from. So conditional access helps IT administrators by empowering users to be productive whenever, wherever, protect the organization assets. So conditional access also provides a more granular multi-factor authentication experience for users. For example, a user might not be challenged for second authentication factor if they aren't at a known location. However, they might be challenged for a second authentication factor if their sign-in signals are unusual or they aren't at unexpected location. So for example, if you try to log in your Google account from unknown browser or a different laptop or something, it will send a mail to your account saying that your account is accessed from unknown device. Maybe you have seen that for even for Gmail or even for YouTube, anything you try to access, you will get a prompt on your mobile device or your account wherever it is configured. Same thing with this also. So during sign-in, conditional access collects the signals from the user, makes the decision based on their signals, and then enforce the decision by allowing or denying the access request or challenging for multi-factor authentication response. Okay, so we still continuing with the conditional access. Now here the signal might be the user's location, the user device, or the application that the user is trying to access. Based on their signals, the decision might be to allow full access if the user is signing in from their usual location. If the user is signing in from an unusual location or location that marked as high risk, then access might be blocked entirely or possibly granted after the user provides a second form of authentication. So enforcement is the action that carries out the decision. For example, the action is to allow access or require the user to provide a second form of authentication. So here we were talking about the signal, decision, enforcement, all. I'm just sharing these pictures to make it more granular for you guys to understand. So next comes Azure external identities. So an external identity is a person, device, service, etc. that is outside your organization. Azure AD external identities refers to all the way you can securely interact with users outside of your organization. If you want to collaborate with partners, distributors, suppliers, or vendors, you can share your resource and define how your internal users can access external organizations. If you are a developer creating customer facing apps, you can manage your customers' identity experiences. So external identities may sound like a single sign-on. With external identities, external users can bring their own identities, whether they have a corporate or government issued digital identity or unmanaged social security like Google or Facebook. They can use their own credentials to sign in. The external users identity provider manages their identity, and you manage access to their apps with Azure AD or Azure AD B2C to keep your resources protected. So couple of times, if you try to log into Facebook or try to log into your Twitter account, it will ask for you want to use your Google account or you want to use your email ID, it will ask. So same thing, like you can also use your own for few applications you can use your own identities to log in to register and log into that. So this picture something shows about like you can see here Facebook, Google. Using these accounts also you can connect to your tenant, like here B2C, this is B2B. So next is Azure role based access control. When you have multiple IT and engineering teams, so how can you control that access they have to the resource in your cloud environment? The principle of least privilege says you should only grant access up to the level need to complete a task. If you only need to read access to a storage blob, then you should only be granted read access to that storage blob. Write access to the blob shouldn't be granted, nor should read access to their other storage blobs. It's a good security practice to follow. However, managing that level of permissions for an entire team would become uh, tedious. Instead of defining the detailed access requirements for everyone and then updating access requirements when new resources are created or new people join to the team, Azure enables you to control access through Azure role based access control, that is RBAC. So Azure provides a built-in role that describe common access role for cloud resources. You can also define your own rules. Each role has an associated set of access permissions that relate to that role. When you assign individuals or groups to one or more roles, they receive all the associated access permissions. So if you hire a new engineer and add them to Azure uh, RBAC group for engineers, they automatically get the same access as the other engineers in the same Azure role based access control group. Similarly, if you add additional resource and point Azure role based access control at them, everyone in that Azure role based access control group will now have those permissions on the new resource as well as the existing resource. So this is the pretty simple picture to explain about the role based access control. So next comes how is role based access control applies to resources. So role based access control is applied to a scope which is resource or set of resources that this access applies to. So here if you see here, scope includes a management group, a single subscription, a resource group, a single resource. So observers, user managing resource, admins and associate and automated process illustrates the kind of users or accounts that would typically be assigned each of these various roles. Roles includes like read, resource specific, custom, contributor, owner. So Azure role based access control is hierarchical in that when you grant access at a parent scope, these permissions are inherited by all child scopes. So we can see here, like when you apply when you apply permissions on the parent, obviously it will be inherited to the child. So when you see the example here, when you assign the owner role to an user at a management group scope, that user can manage everything in all subscriptions within the management group. When you assign the read only group to role to a group at the subscription scope, the members of the group can view every resource group and resource within the subscription. So when should I use active Azure role-based access control? So here, like allow one user to manage VMs in a subscription and another user to manage virtual networks. Allow a database administrator group to manage SQL database in subscription. Allow user to manage all resource in resource group such as virtual machines, websites and subnets. Allow an application to access all resource in the resource group. There are just a few examples. You will find the complete list of built-in rules end of the module. So how is Azure RBAC enforced? So Azure RBAC is enforced on any action that's initiated against an Azure resource that passes through Azure Resource Manager. Azure Resource Manager is a management service that provides a way to organize and secure your cloud resources. So you typically access Resource Manager from the Azure portal, even Azure Power CLI or Azure PowerShell and the Azure CLI. So you can manage like same thing will happen from the multiple accesses, but we will use multiple methods. So Azure RBAC doesn't enforce access permissions at the application or data level. Application security must be handled by your application. RBAC uses an allow model. When you are assigned a role, RBAC allows you to perform certain actions such as read, write or delete. If one role assignment grants you read permissions to a resource group and a different role assignment grants you write permissions to the same resource group, you have both read and write permissions on the resource group. So we will discuss, we will do these all stuff when we work in the lab. So yeah, till now we need to understand the things so that it will be easy when you work. So now we will discuss about Azure Zero Trust model. So Zero Trust is a secure model that assumes the worst case scenario and protects resources within that expectation. Zero Trust assumes breach at the outset and then verifies each request as through its oriented from uncontrolled network. Today, organizations need a new security model that effectively adapts to the complexity of the modern environment, embraces the mobile workforce and protects people, devices, applications and data wherever they are located. To address this new world of computing, Microsoft highly recommends the Zero Trust security model, which is based on few of the guidelines like verify explicitly, always authenticate and authorize based on all available data points. So use least privilege access, limit user access with just in time and just enough access, risk based adaptive policies and data protection. So assume breach minimize blast radius and segment access, verify end-to-end encryption, use analytics to get visibility, drive threat detection and improve defenses. So adjusting to Zero Trust, traditionally corporate networks were restricted, protected and generally assumed safe. Only managed computers could join the network. VPN access will tightly controlled and personal devices were frequently restricted or blocked. The Zero Trust model flips that scenario. Instead of assuming that a device is safe because it's within the corporate network, it requires everyone to authenticate, then grants access based on authentication rather than location. So this is somewhat this picture shows about the Zero Trust model, which we can simply simplifies the understandability. So next comes the defense in depth. So running on premises means that the company is responsible for all aspect of security, from physical access to the building all the way down to the data travel in and out of network. The company wants to know how its current defense in depth strategy compares to run in the cloud. So the objective of defense in depth is to protect information and prevent it from being stolen by those who aren't authorized to access it. A defense in depth strategy uses a series of mechanisms to slow the advancement of attack that aims at acquiring unauthorized access to the data. So there are 7 layers in defense in depth. Each layer provides protection so that if one layer is breached, a subsequent layer is already in place to prevent further exposure. This approach removes reliance on any single layer of protection. It slows down an attack and provides alert telemetry that security team can act upon either automatically or manually. So you are able to see the 7 layers. I will just brief about each one. So the first one is a physical layer. Physical security layer is the first line of defense to protect computing hardware in the data center. So identity and access layer controls access to infrastructure and change control. So the perimeter layer uses distributed denial of service, that is DDoS protection, to filter layer scale attacks before they can cause a denial of service for users. So the network layer limits communication between resources through segmentation and access control. Next is compute layer secures access to virtual machines. Application layer helps ensure that applications are secure and free of security vulnerabilities. The data layer controls access to business and customer data that you need to protect. So these layers provide guidelines to you to help make security configuration decisions in all layers of your application. So these are the layers which we are talking about. So next comes Azure provides security tools and features at every level of defense in that concept. Let's take a closer look at each other. Okay. So physical security layer, like we already discussed this, but I want to show briefing them. Like here you can see that first layer, physical layer, identity layer, perimeter layer, and network layer, compute layer, application layer, and data layer. So next go to okay. So Azure provides security layers. So these are all we already discussed. So next comes defense for cloud, Microsoft Defender for cloud. So Defender for cloud is a monitoring tool for security, posture management, and threat protection. It monitors your cloud, on-premises, hybrid, and multi-cloud environments to provide guidelines and notifications aimed at strengthening your security posture. So Defender for cloud provides the tools needed to harden your resources, track your security posture, protect against cyber attacks, and streamline security management. So deployment of Defender for cloud is pretty easy. It's already natively integrated to Azure. So just ensure that applications are secure and free of vulnerabilities. So Defender for cloud fills three virtual needs as you manage the security of your resource and workloads in the cloud and on premises. That is like continuous access, secure and defend. So that's all for this video. It's I know it's pretty long video, so I hope this is informative for you guys. And yeah, most of the topics I discussed, when you go for AZ900 you will get questions on layers, and security access, like you get tons of questions from this topic. So thanks for watching. Please do subscribe and like my videos, and always reach out to me on my mail id vstudentblog@gmail.com. Thank you. Bye bye.